So probably I will start the discussion asking on a generic overview. If I know most of you are using building simulation, dynamic simulation, CFDs, and transient models to model your spaces. Now that you've learned how to use the software, because I'm sure most of you have undertaken, learned that software throughout your courses, how confident do you feel that you can now go back to the industry and say, yes, I can consider myself an expert on this topic and I can undertake other studies that are related and using this particular software or something in a similar line? Anyone that wants to answer?
Maybe because I'm holding the microphone, I'll start. Thank you for the question and thank you, the audience. For me, I think that question is very personal. It depends on the personal experience that we all had. I happen to be using about 4 different software in my work, and maybe I'm very lucky with the support of my university. I have coaches from each of those software companies assigned to me. So I'm really working with people who are practitioners who coach me how to use. And I think that's the experience I've had. And based on that, I am confident that I'll be able to relate, I'll be able to work at an industrial level with those software. And also from my experience, I have worked in industry for over 20 years before I came to school. So I also have that contact. So I think it's really personal, peculiar to each person. So
well, for me, since I'm using NVMet software, I don't know if you use NVMet software here, but it's quite painful to use. But because the simulation takes like a day or a week, and if you have a lot of simulations to run, it's really painful. But in terms of confidence, since I'm also doing green walls, if they would release a version that green walls accumulate for air pollution, then I would be happy to, because for now when in my study it's not really fully realized because of this simulation. It's still not yet ready in the software itself. But other software that I'm also like willing to learn. But for now, the NVMet has some limitation, and along the way, it was discovered. So.
For my study, I used 2 softwares, Rhino and Climate Studio. And I think for the 3 models that I've worked on, they're quite complex in terms of how they are. And I think it worked well for me. I have no complaints with the software, and I feel confident with those softwares. That's it.
Yeah, I also feel mostly confident about the software. I would say I feel the most confident that I will keep on learning if I need to. So yes, but green walls in AES are not easy to model, and so figuring out how to model it was a challenge. But it also helped me understand the software in itself better. So yeah.
Yeah, I would say that I'm kind of confident. Like during my degree, I started using this kind of software, but I would say that I just prioritize using it for designing housing. So I don't have any experience in like buildings, like office buildings. So I think that if I jump into the industry, I would have to learn about that more.
Yeah, I'd just like to add on to what everybody said. Yeah, we do feel confident about it. But I also have a different take to it as to how our clients would observe that or how they would react to it. I think that would be interesting to understand what they'd like to see more than what we also like to do with our softwares.
Is there any question from the audience?
Yes, yeah, it's probably a comment because I mean all your projects are quite complex, even though you're using the software, and I guess that complexity give you a different level of understanding of the software, which probably if you have done something more traditional from a design point of view, from a use of the software, will have probably not achieved as much as you have achieved. So I think it's good that the level that you have done. And I have a question for the experimental work. I took a note, but then I didn't ask you before. You divided your sample of Indians and Chinese. And why? Why Indians and Chinese? Is because you have people from those two countries coming and being participant on on your study? And do you think that is really relevant between the two of them? I mean,
First point would be it was easier for me to get those participants to participate because they were mostly my classmates. So it was easy for me to ask them to fill the ethics and take their consent. But also it was, at the end of the day, it was about the kind of construction house they come from, the style and the materials they use. So I thought that would give a different take to mine because when you compare concrete to timber, the kind of vibrations felt in concrete would be entirely different to people who stay in a timber house and perceive vibrations, so that they have higher perception and higher tolerance as compared to people from concrete, because they don't know what it's like to feel those vibrations because they easily get absorbed in concrete. So that was one of the main differences why I chose different nationalities, but these were the nationalities available to me easily. But I did try to take people from different countries like Mexico, England, and yeah, they too had a different intake to it, but it was a minute difference. But yeah, at the end, when I have a higher sample size.
okay, the first thing that came to my mind when you were talking about the vibration is that people coming from specific countries have experience, for example, with earthquakes. So a person coming from, let's say, Japan, probably you have a grade or 6 degrees earthquake. It's going to be extremely, they're going to feel that it's nothing. But a person coming from a country without earthquake at all, probably they can feel the vibration. So is this something that you look at? Because probably, I don't know, in India you have, you have earthquakes depending where you come from the country. And in China, I'm not so sure if they have earthquake, probably in the mountains they have. Is that something that you look at?
I did want to look at, but it, as I said, I did look into it, but it didn't really make a huge difference because my sample size was very minute. But I had one person who told me that she's an architect and she goes to sites, so she feels those vibrations and she's like, I'm used to those vibrations. I don't find it different. So that was another different interesting thing, that even though she came from a different country, but her working in a construction site and feeling those vibrations. So that is again a point that could be considered other than just nationalities.
Okay, thank you.
Thank you.
Hi, so it's probably for Raymond, Naomi, and Aditi. It's a link with green wall. So you have green wall in your study, and for me, it's this kind of, yes, you benefit outdoor, but what about indoors? This outdoor-indoor ratio of benefit and to your study. So Raymond, I don't think, yes, it increased, the comfort or the environment within the street canyon, but what is the impact indoor? And what do it's kind of like for the three of you, would you consider this in future study, how you can work together, maybe?
I mean, from some research background, I've read about it, but I haven't measured it, so I don't know exactly the impact. But maybe he can answer better. I didn't look at the purification of hair, any aspect of that.
I think it's same. I think if I understand the question, like the impact in the indoors. So basically, the objective of my study is just on the pedestrian level because it's the overheating and also the pollution, and and therefore I cannot really answer because it's not part of the scope, but it's another avenue to discover and to study as well, because the urban climate is already complex study, and the duration is also not enough for the study. So, but yeah, it would be interesting as a subject. Yes.
I was
Hi, just a sec. I have two very specific questions, one for Mahima and the other for Numi. And the first one is, in your study, what will be the source of the vibrations you're emulating? Like, is it like something coming from wind, occupancy in some places where maybe the slabs are very lightweight, or for example, on these two rooms, there is a big portion that is cantilevered, and if you go there when it's quite a windy day, you feel like a constant earthquake. So is it like, what's the source of this, and therefore what will be the applicability of this study?
So there were two sources that were identified. There was external source and internal, but what I focused on more was internal sources, and it was not physically induced. It was just when people were walking or running, they could feel it on the corridor while someone was working on the desk. So that was one of the sources that was mostly identified, was just by people walking or running on the corridors. And coming to mitigating them, I didn't look into how we could mitigate. Mine was more about focusing and observing that vibrations do exist and should not be neglected. So yeah, that was one.
Thank you. And my other question about the biodiversity strategies is that I feel it's quite complete from an environmental point of view, but maybe in this short presentation, you didn't have time to touch also the economic and social side. And I mean that you mentioned that architects, policymakers, and developers should jump on this trend, rightfully. But what about the occupants of the final building? I mean, in layman's terms, how do you convince people that spending money to have bees, flies, and spiders as neighbors is a good idea?
Yeah, that was one of the main topics in the interviews. But the main thing is, when people understand that bees will not do anything, or insects will not do something bad to us, I guess most of it is for knowledge. And when we understand how it works and how little they are, people are quite fastly okay with it. One of the interviewee really talked a lot about education. That was really interesting. They do a lot of work on people's minds around that. And they like really talked around, when people are younger, it's more easy to make them understand how nature is good for us. And if they understand, if they go outside since really young, then adults will be okay with that too as well. I guess we're so separate from nature now, at least our generations. And that shows in our well-being and our mental health. And we all understand that if we go into nature, we'll feel better afterwards. So if nature is around us, near our houses, then we will all feel better too. We all kind of personally understand that. But if we understand, like, nothing will happen if there is a bee inside my house and then go outside again, like it goes away, the fears goes away pretty fast. But some people are really afraid of them, yes. I guess designer need to understand that in which houses we'll have, it needs to be personalized. Yeah. Yeah.
To add to this topic, I'm sorry, I'm asking the question to the same person, so you will have to talk more. Now, first of all, regarding the neighborhood with the mini beasts, I think is interesting to think that in the past the attitude was very different. You know, if you have a wasp nest or a bee's nest next, you know, on the eaves of your roof or next to your window, you will call pest control, because also there is an appreciable risk that people can have allergies to the insect bites and have anaphylactic shocks, etc. So I think it is although we would like to romanticize it, I think it is a big task to convince people to have that. I'm not saying that detracting from the whole idea. I think is great and we should do it, but think of more practical ways, for example, to appease people and say maybe you need to put insect mesh or something on the window and things like that, that then can still allow for natural ventilation, opening windows at the same time protecting from insects. So that's one thing. And the other, going back to the question about simulation, and you say that it was difficult to simulate in IES the green walls. And I wanted to know if you had at all considered, how did you do it? And if you had considered the concept of emulation instead of simulation. And I can explain what I mean by emulation in the sense that in the past, when we, with the students or with the specific software, we were not able to simulate a specific process, like, for example, evaporative cooling, then the emulation will allow to input in the thermal, talking specifically about thermal dynamic simulation, input the output conditions of the process when already happens, so that then can feed into your model and essentially, rather than simulate, emulate what would happen if we had an evaporative cooling or an evapotranspiration in the case of the green wall. Did you consider at all that as a process for mediating the limitation of the software?
I guess that's the right term to say what I've done. So it's basically emulating room in itself.
I use the word emulation, and I've used it also in a book on natural cooling for evaporative, passive evaporative cooling, because obviously it's not exactly a simulation.
Okay, yeah.
Yeah.
So I never heard that word before.
Maybe you can use it.
Yeah, now again. So yeah, it does. So it's basically a room acting as what a green wall would do with evaporative cooling. So like solar absorptivity of the plant, a lot of different aspects that I had to put in as if it was plants instead of a typical brick wall. So I guess that term is right, yeah.
Thank you.
Of course.
Following on simulations, I would like to make a comment that it's very useful. Simulations have been amazing and have developed a lot in the past few years. 20 years ago, when I did my PhD, was a nightmare. Now it's much more easy, and I'm sure Rosa had the same experience. But one advice is always question yourself. Always question the results. Quite often, how you've it nowadays, even with software where you just tick boxes, that sometimes it produces a result. You need to always question if the result seems real. And it's very, very interesting. And some of you have done as well real measurements and making the comparisons to substantiate your claims. But it's also fine to address the limitations and clearly publish what are your constraints, to clearly say this in this particular scenario works, but we can only suggest or guess how we would behave in a different scenario. Otherwise, we will have a significant gap, as the first speaker highlighted, and I'm sure most of you have experience. You simulate in an ideal scenario urban canyons. There are no obstructions, there are no protrusions in the facades, all the buildings are leveled. So it's simplifications that are very important to highlight. Having raised that, any more questions? Absolutely,
Yeah.
you're most welcome.
Thank you very much for contribution, because yeah, it's the issue with simulation. That's the drawback. But what's the other option? Maybe there's really none, because this is the state of the technology. This is what we have. We cannot go back to using slide rules and all of that because we have drawbacks. But going forward, I think, and it's one of the recommendations I was trying to make, we need to do more measurements, more actual measurements. And in this way for buildings, I'm really happy with the policy of BIM in the UK. So we need to develop that culture so that from the beginning of the construction of a building, from the design, we have all the properties of all the materials on the data sheet as part of the BIM file, and then we can take the BIM file into the simulation software with the real data of the bricks, the floors, the insulation, and then working with this real data and probably using real measurements, we can begin to have values that are more credible, let me use that word, more valid, maybe. And that can be the basis of benchmarking, because today the performance gap issue is still there. What the energy certificates are saying is not exactly what is obtaining in the operations, because the energy certificates themselves are based on some assumptions in the assessment procedure and all of that, and in the calculation methodology. So my suggestion would be we need to really develop this measurement and data culture to improve simulation coach practice going forward. Okay.
Hi, I have just one question. For me, the strength of simulation is testing, looking at variability, looking at the extreme cases and kind of like the standard cases. But I didn't see that much. I suppose it's a time limitation of the MSc compared to a PhD, when you start really pushing and having thousands of simulation going through, and you can really start seeing not just a bar plot, just seeing variability, probability functions coming out of your simulation. But coming back to that, for the on variability, one is seasonality. And sorry, Raymond, is the case for you. It's outdoor pollution varied a lot with, of course, outdoor weather. But if, for example, rain, when you think about NO2 concentration, outdoor NO2, one of the pollutant. Did you check for different seasons or weather patterns or future scenario? What will be the change in the urban canyon?
In terms of NO2, like I did check for the whole year, but there's no pattern. It's very variable, so it's also difficult to pinpoint like which month, which. So it's just based on the selection of, and stick to that one, because it's, as I said, it's really difficult to predict. There's no pattern at all. Sometimes, for example, like morning and afternoon. Sometimes in the morning it can be higher, sometimes in the afternoon. So there's this huge variability, and it's also difficult to predict which one. So that's why there's further research that's needed to do.
One thing about simulation. When I first started teaching in schools of architecture, every good school of architecture had what was called an artificial sky. They had a wind tunnel. They'd have a simulation thing for the temperatures in the buildings. It was all done by comparison between different things. You know, the artificial sky would have a flat top and mirrors all around, so that you've got effectively an infinite sky, as you do outside. The problem with that is that, firstly, they're not as accurate as you'd like, but nevertheless, I suspect the inaccuracies were no real problem. They weren't caused by the system, they were caused by the fact that, you know, you can't create an infinite sky, and an infinite sky anyway that never exists. So out there you see clouds and so on, and but the tendency then was to go over to doing simulation, electronic simulation, because they could do it. And whether the two you have to be very careful, you know, you can't sort of say that the artificial sky was better than I don't know what the, what the thing is, but but I do think that what we need to do, I think you're probably right, that what we need to do is to make sure that what we're simulating or what we're predicting from the simulation is actually a reflection of what's really happening. And I don't think there's any way in which a digital simulation can be terribly precise, because it's digital, you know, it doesn't assume. So I think you're right. I think we do have to, but we have to realize that there are, you know, it's something we need to be able to do to predict what will happen. And let's make sure it's done as precisely as possible. I mean, you know, that in your thing of the green walls, you know, how much effect does the green wall have on the U value of the wall behind it, and so on? Those sorts of things need to be clearly understood and simulated in a realistic, as realistic a way as possible.
Just to wrap up on what Fergus said and a little bit of advertisement, I'm sure you're all aware of the UK Net Zero Building Standard that is clearly addressing the new policies and trying to do a bottom-up and a top-down approach based on the climate, and is relying on real data, looking at real buildings, but it's also relying on simulation. So there was a call a couple of months ago for case studies. Specifically, there was on various typologies. The standard is now, the consultation has ended and we're looking at what's coming out of it. There is as well operational energy and embodied energy for the whole life carbon assessment. So it's very important, and I'm sure you all as researchers will carry on doing research, and if not, being always updated, because if you think it ends at the end of a master's, you're thoroughly wrong. It carries on throughout all your life. And that's a note just to go for coffee or tea at the end of, and a very quick short break. And see you on session 4.